radicals, simplifying radicals, and finding the discriminant and standard form. So the first thing it's asking us for is the standard form of a quadratic equation. So since we're solving our quadratic, what do we do to solve a quadratic? Yes, you can. Thank you. When we want to solve a quadratic, we have to set it equal to what? 0. So we're going to start off with a 0. Then we're just going to plug in the standard form. So standard form of a quadratic, 0 equals a page 19. Okay, page 20 then. To 11. Got it? It says 211 simplifying radicals. So ax squared plus bx plus c. All right. Well, it's asking us about a discriminant, and that's something that you guys may have learned in Math 1, but I'm going to give you some back information. So I'm going to write something right here. I'm going to write down the quadratic formula, and I'm actually just going to write quad formula. So the quadratic formula is x. If we're going to solve something, x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So when we talk about the discriminant, we're actually just talking about the b squared minus 4ac. So I'm going to kind of slide back over and write that. I'm going to shrink it up so you can see both. So when I'm talking about the discriminant, I really just want to know the value of b squared minus 4ac. So if I'm going to do this, I have to make sure that my quadratic equation is written in standard form. If it's not written in standard form, I'm going to make some mistakes. Okay, if it's not written in standard form, I'm going to make some mistakes. What are you doing there? Yeah, just close your Chromebook. Close it. Yeah, thanks. Okay, so let's look at this first one. Again, we're just trying to figure out b squared minus 4ac. So when I look at this first one, it says find the discriminant for the following quadratic. Is a written in standard form? It is. So I'm going to write out what the value of a is. What is a? 1. I'm going to write out what the value of b is. 5. And I'm going to write out the value of c. So the discriminant is b squared, so 5 squared, minus 4 times a times c. Well, you could either A, put all of that into your calculator, or B, use your super happy thinking brain. 25 minus 8 is 25 minus 8 is 17. If you guys have filled out notes, I think that says 13 because I did this really late at night. You probably want to fix that. It's 17, not 13. Sorry, guys. 17. That's so funny. Okay. So let's look at our next one. Let's look at example. I'm going to go across the page. Example C. Are we in standard form? No, we're not. How am I going to put this in standard form? Yeah, I have to subtract that 8n from both sides. So when I do that, I have negative 7n squared plus 8n equals 0. So what's the value of A? A is negative 7. What's the value of B? And what's the value of C? 0. Good job, you guys. Okay, so B squared. That's 8 squared minus 4 times A times C. Well, 0 multiplied by anything is 0. So I just really have 8 squared, which is 64 minus 0. So it equals 64. Are we okay with that? Okay. What about our next example? Example B. Is this in standard form? What do you got, Tyler? So I want everything on either the right side or the left side. So let's move it all. I don't care which way you move it. I want everything that's on, I want all of the terms to be on either the right side of the equal sign or the left side. So we could add 7 and add 9 to both sides, add 7x and add 9 to both sides, or we could add 6x squared and 6 to both sides. It doesn't matter, but we have to make one side have nothing, right? One side has to have nothing on it, has to equal 0. So when I do this math and I put this in standard form, what do I have? Good job. Perfect. Negative 6x squared plus 7x plus 3 equals 0. What's the value of A? Negative 6. What's the value of B? What's the value of C? 3. So B squared, that's 7 squared, minus 4 times A times C. So 49 minus, let's see, a negative times a negative is a positive. So this really is going to become 49 plus 72, I think. Yay or nay? Who's calculating that for us? Yeah. So 49 plus 72 is? Perfect. 121. Okay. I'm going to go to this last one. Who can get this one in standard form for me? 3x plus 4 to both sides. Plus 3x plus 4. What's that give me? Good job. 4x squared plus 8x plus 4 equals 0. What's the value of A? What's the value of B? What's the value of C? So B squared, 8 squared, minus 4 times A, which is 4, times C, which is also 4. So 8 squared, well, that's 64. And 4 times 4 times 4, well, that's 4 cubed, which is also 64. So what is 64 minus 64? 0. Not no solution. It just has a value of 0. Okay. 0 is the value of the discriminant. It's going to tell you something when we start the quadratic formula. So we want to make sure you know how to figure out the discriminant first. Okay. All right. So you're just trying to figure out what b squared minus 4ac is. Make sure that your equations are in standard form. Identify a, b, c. You guys feel like you can do that? Okay, good deal. Now we're going to talk about simplest radical form. And simplest radical form means that you can't have any, it says radicands. Nothing in a radical symbol can have perfect squares inside of it. That's why we wrote all the perfect squares on the back of your times table for you, right? So we don't want any of these inside of it. You can't have a fraction inside of a radical, and you can't have a radical in the denominator, okay? So we're going to start talking about how to simplify that. So the first thing that we want to do is when we have a radical symbol, we want to break it into 2 factors. We want the first one to be a perfect square or a perfect cube, because sometimes we do like square roots and sometimes we do cube roots. So we want it to be the first term to be a perfect square or a perfect cube. We're going to take the root of the perfect number out of the radical and then leave the not perfect number inside the radical. So let's just talk about that. Look at your numbers on the back. Look at your numbers on the back. Are there any numbers that you believe are perfect squares that we can divide 180 by? And we really want the largest one. We want to have the biggest number that you can find, but we'll start with a small one if we need to. I just can't write that small. Do you know what I mean? Like I can't fit it in the box. That's why I crossed it out. What? 13. I want a perfect square. I want to look at your perfect squares. Perfect squares. 4, 9, 16, right? 25. Is 180 divisible by 144? No. How about 9? I mean, it's 18, right? So you think that we could take 180 and divide it by 9? Yeah, I think so. Okay, so I'm going to write it as a product. 9 is a perfect square, so I'm going to put that first. So I have the square root of 9 times the square root of 20. Okay. Someone tell me, what is the square root of 9? It's 3. The square root of 9 is 3. Okay. Times. Oh, that is so cute that did that. That did that all by itself. Made a heart. How nice. Okay. Anyway, so I'm sorry. Yeah, that's for you guys. So tell me, what can I do with 20? Does 20 contain a perfect square? Can I break it up? Let's see. Perfect squares. 4, 9, 16. Do the numbers 4, 9, or 16 divide 20? 4. So I'm going to break up the square root of 20 as the square root of 4 times the square root of 5. But I got to bring this down. What is the square root of 4? It's 2. So what is 3 times 2? 6. So the square root of a 180 is the same thing as 6 times the square root of 5. It's the same thing as 6 times the square root of 5. So I just want to show you, if you wanted to check that, you take your whole number that you have on the outside and square it and multiply it by the radical value on the inside. Our whole number on the outside, square it, multiply it by the radical value. What is 6 squared times 5? It's 180. Look at that. So we simplified that perfectly. Okay. So let's do it again. We're trying to divide it by perfect squares. We want to break it up into perfect squares. So I have 125. So let's see. Perfect squares. 25. Yeah. How many times does 25 go into 125? 5 times. So the square root of 125 is the same thing as the square root of 25 times the square root of 5. So this is very cool because you can actually break this up into a product, right? You are just like you can say the number 6 is the same thing as 2 times 3. The number 125 under a radical, the square root of 125 is the same thing as square root of 25 times 5. Tyler, question. Well, 5 is not perfect, right? 5 is not perfect, but what is the square root of 25? 5. So this actually turns into 5 times the square root of 5. Because remember in our directions, it says you're going to break the radicand into 2 factors. You want the first one to be perfect. 25 is a perfect square. You want the second one to be a not perfect square or perfect cube. Okay. So this is your final answer. Okay. Let's keep going. Whoa. What about this? You can break it up into small numbers. It doesn't have to be 60, or would you say 16? Yep.
60.
Oh, 60 is not a perfect square. You got to do perfect squares. You can only start with a perfect square. 64. Okay. So 3,200 divided by 64 is what? What is it?
It's 50.
50. Okay. Let's start with this. What is the square root of 64? 8. Perfect. So I have 8 times. Let's look at the square root of 50. Is there a perfect square living inside of 50?
Yeah.
Which one?
25.
25. Yeah. 50 is the same thing as the square root of 25 times the square root of 2. 2 times 25 is 50, right? Okay, so what is the square root of 25? So this is really 8 times 5 times the square root of 2. And what is 8 times 5? So this really simplified all the way is 40 square root 2. Colt, can you say what you said originally? Yeah, we could. Originally, he said we could do 1600, but we'd already started. And so I shushed him. Good job.
Yeah.
Because 40 times 40 is 1600. Good job. Yeah. Okay, are we good? Let's keep going. All right. So here's some rules. So criteria number 1, you cannot have a perfect square left underneath a radical. Cannot have a factor of a perfect square. Okay. Number 2, you cannot have a fraction underneath a radical. How do you think we're going to get rid of that? No decimals. These are all exact answers. I'm going to show you this magical trick. Watch. You ready? I'm going to break up my fraction into 2 pieces. The numerator is going to be the square root of 4, and the denominator is going to be the square root of 25. I just broke it up, right? So what is the square root of 4? 2. And what is the square root of 25? There we go. No fractions under a radical. It says no radicand can contain a fraction. We got rid of the fractions, right? There's no radicand. We just got to. It's not. So is our final answer in a radical symbol? Does our final answer have a radical over it, a radicand? Like, no, it doesn't. So it's just a number. Okay. So the rule is you cannot leave a fraction inside of a radical. If you have a fraction in a radical, it's not simplified. Our answer is not in a radical. Okay. Let's keep practicing. What do we know about this one? We could write it as 98 over 8. I have a question. Is 98 divisible by 8? Can you check on your calculator? Okay, so it only goes in there 96 times. So we have to write this like this. The square root of 98. Yeah, but I wanted you guys to see something. If you can simplify the fraction, do that, right? You okay over there, bud? I feel like you're rearranging the room. Bad chair? Okay. So the square root of 98 over 8. So I want you to think about what number, what perfect square lives inside of 98. What perfect square times, it's not divisible by 9. 2 is not a perfect square. What is 7 squared? It's 49. So 98 is the same thing as 49 times 2. So we're going to write the square root of 98 as the square root of 49 times the square root of 2. Because 49 times 2 is 98, and we know that 49 is a perfect square. So the first term is a perfect square. The second one is not perfect. I don't know why this is so hard for you, Trey. Stop being like negative and just listen. I promise you. Talk to me about a perfect square that lives inside of 8. Look at your chart. Yeah. So how do I write? So what's another way to write 8? 8 is the same thing as 4 times what? Shut it. 4 times 2. So the square root of 4 times the square root of 2. So when you guys learned how to simplify fractions, you learned that you could break fractions up into products, right? Or factors. Do you see that you have the exact same term in the numerator as you do in the denominator?
Yes, I see what you're doing. You're basically multiplying backwards, kind of.
I am. I'm breaking that first radicand into a product of 2 other radicands. And I want one of them to be a perfect square so I can simplify the radical. Okay? So do you notice that you have, what is the same exact term in the numerator as the denominator?
2.
It's not 2. What is it?
2.
The square root of 2. Okay. So do you see that if you have the same exact term in the numerator and in the denominator, you can just cancel it out? I mean, what is the square root of 2 divided by the square root of 2? Put it in your calculator. It would be 1. I'll show you in a minute. It would be 1. The square root of 2 divided by the square root of 2 is 1. Anything divided by itself is 1, right? Okay, so those cancel out. What is the square root of 49? 7. And what is the square root of 4? That's your answer. Okay, this next one is going to just make you want to vomit. So make sure you got your happy face on because I know that you're going to be like, what? Are we ready? Okay. So you told me that the square root of 2, I'm just going to write it up here, that the square root of 2 divided by the square root of 2 equals what? It equals 1. Yeah. Isn't 3 divided by 3 1? Isn't x squared divided by x squared 1? Yeah. So as long as it's the exact same term in the numerator and the denominator, they cancel out to 1. So when I break this fraction up, God bless you, and I write it as the square root of 1 over the square root of 5, 5 doesn't contain a perfect square. I can't simplify that. So I have to figure out a way to get rid of that square root of 5 in the denominator. I can't leave a square root in the denominator. It's illegal. So is there a fancy number 1 that I can multiply by? And when I say a fancy number 1, I mean like, is there a way that I can write a number 1 so that it'll get rid of the radical in the denominator? I think there is. I think I just did that right there. What is the square root of 5 divided by the square root of 5? Hang on. Shh. Say what you're asking, Trey, because I think that you know what you want the denominator to be. No. Where are you getting? No. You're right. You're saying that the radical, like when I simplify this, when I multiply these two together, I get the square root of 5 over, it's not 25ths, it's the square root of what? 25. Okay, you're exactly right. But Trey, what is the square root of 25? 5. So it becomes the square root of 5 over 5. And now I've gotten rid of the radical in the denominator. So I just want you to look at something up here really fast. This is important. When you take a square root of anything and multiply it by the square root of that exact same thing, like the square root of 5 times the square root of 5, what do you actually end up with?
5 over 5.
No,
Square root of 5.
just focus on the denominator. The square root of 5 times the square root of 5 eventually ends up equaling 5. Just like if I were to take the square root of 487 times the square root of 487, eventually it's going to end up just being 487. Okay? Because a square root multiplied by itself cancels out. Well, why does that work? Well, because it's the product rule. 5 times 5 is 25, and the square root of 25 is 5. So I'm trying to get you to understand that you can actually skip this step. Does that make sense? Okay, Andres, are you with me? Looks like you're barely hanging on. Okay, slide down to the next one. Okay. So it says, hey, you can't have any radicals in the denominator. That's called rationalizing the denominator. It's called rationalizing the denominator. And all we're doing is we're not changing the value of the fraction because all we're doing is multiplying the fraction by 1. We're just multiplying it by 1. It's just a weird looking 1, right? So what is the value of the denominator in this question? It's the square. So I have to multiply both the numerator and the denominator by. So hang on, let's multiply straight across. So 1 times the square root of 3 is just Yeah, that's exactly what it is. The square root of 3 over 3.
Anytime one's on top, they put the square root of the bottom number, which is 3, that number on the bottom.
Shh. Don't think of it like that because you're going to just jack yourself up when we start doing cubes. Okay? Just know the rule. Know the rule. You multiply whatever the denominator is under the radical. That's what you're multiplying. You're rationalizing the denominator. Okay? So let's look at the next one. What do I want to multiply? What fancy looking number 1 do I want to multiply by? It's not 2. It's the square root of 2 over the square root of 2. Yes. What does that become? What is 4 times the square root of 2? That's just like saying 4x, right? We're just multiplying. Okay, listen, stop. This, I did say, you cannot take a whole number and multiply it by a radical. We haven't done that anywhere. We've taken a radical and multiplied it by a radical, but not a whole number, okay? So this is no different than saying 4 times x. So this becomes 4 times the square root of 2. The denominator, a radical times a radical. The square root of 2 times the square root of 2 is the square root of 4, which equals what? 2. So now look at the whole numbers or the constants. Can you simplify 4 over 2? It just becomes 2 over 1. So this really simplifies to 2 square root of 2. Okay. Fancy. What am I multiplying by? Say it right. Over. Okay. So the numerator becomes what? 2 times the square root of 3. Perfect. The denominator becomes, what is the square root of 3 times the square root of 3? The square root of 3 times the square root of 3 is the square root of 9, which is 3. Yeah, remember, if you multiply the same radical by itself, the radical evaporates, like it just melts away. So this becomes 2 root 3 over 3. 2 root 3 over 3. Okay, you guys have 3 more. I want you to try them. Mm-hmm. Can you show me what you're talking about? I want you guys to try at least number that first one. Practice, you try. Okay, well, so I have to, this is just 1. The square root of 2 over the square root of 2 is 1, right? I can't change the value of the fraction. I can't change the value. I just have to get rid of the denominator. So I'm just multiplying by a fancy looking number 1. You have to multiply by whatever is in the denominator. So the square root of 2 over the square root of 2 is just a fancy way to write the number 1. And when I multiply these two together, I get 2. So I get 4 times the square root of 2 in the numerator over 2 in the denominator. And then I can divide. What are you going to multiply by in this one? Square root of 2 over the square root of 2. Okay. So what is 8 times the square root of 2 become? Perfect. Keep going. Can I simplify that? 4 square root of 2 over 1, which I just don't even need to write that over 1, correct? Just leave it like that. Trey, I knew you would get it. Okay, what about this next one? What's my fancy looking one when I separate these? I have the square root of 20 divided by the square root of 7. What do I have to multiply by to rationalize the denominator? Over the square root of 7. That's just a fancy way to write the number 1. So 20 times 7 is 140. The square root of 7 times the square root of 7 is 7. So is there a number, is there a perfect square that lives inside of here? I'm sure there is. Let's break it up. What's 140 divided by 4? It is not. What is 140 divided by 4? It's 35. Okay. So 35, let's see, perfect squares. 35 is not divisible by 4. It's not divisible by 9. It's not divisible by 16. It's not divisible by 25. The next perfect square is 36. We're already bigger than that number, so it can't be simplified. So what is the square root of 4? 2. So I have 2 times the square root of 35 over 7. 2 times the square root of 35 over 7. Do you guys remember when you learned prime factorization?
Isn't that like 2 plus 6, 8?
Well, it's when you take a number and you break it up by its like a product of its primes. Huh? What'd you say again? It's a what? 4, 6, 8 is composite. 2 is prime. Okay, so let's look at 108. Let's break up that square root of 108. The negative 2 is still going to come out front. Let's see. What are 2 numbers that multiply together to equal 108? One of them has to be a perfect square. Okay, 9 and 12. Perfect. Trey, what is the square root of 9? Okay, so now I have negative 2 times 3. I have a question, Trey. Can the square root of 12 be broken up as the product of a perfect square and a non-perfect square? Square root of 4 times the square root of 3. So I'm going to simplify. Let's see. Negative 2 times 3 is negative 6. And the square root of 4 is what? 2. So I have negative 6 times 2 root 3. What is negative 6 times 2 root 3? You just multiply your constants. Negative 12 root 3. That is it.